this video, we're going to talk about rotations. Say rotation. Rotation about a fixed point, called the center of rotation through an angle of x, is a function that maps a point to its image such that the point is the center of rotation, the image and pre-image are the same point, the point is not at the center of rotation, then the image and pre-image are the same distance from the center of rotation, and measuring through an angle of rotation. Okay, that's a lot of stuff. Not gonna lie, just even reading that, I'm like, what's going on here? So what we have is C is our center, and we have a distance to our image, okay, which is A. I should say the pre-image. And then I rotate 120 degrees. This distance from A to C to our image, what I get after, that is A prime. Okay? Okay, so what this all means. Rotations in the coordinate plane. This is what we're going to be doing. And we are going to assume that we are going counterclockwise. I didn't write that on there, I apologize. So I have a point here, and my point is the point 3, 2. And I want to rotate that counterclockwise about the origin, 90 degrees. So that means that this needs to be a 90-degree angle here. Well, how do I make a 90-degree angle? I look at the slope of this line, which is 2/3, and my perpendicular slope would be, so my slope in this case is, I'm sorry, it's not 3/2, it's 2/3. My perpendicular slope is -3/2. So from my center of rotation, I go down 3, left 2. That doesn't make any sense. Okay, so I figured out what I did wrong. Okay, so you could go, so we need a 90-degree angle. I need it to rotate 90 degrees this way. So I could go, where I got confused was, I could go down 3 and then right 2. Well, that's going to get me something down here. That's not 90 degrees counterclockwise. I can also go up 3 and left 2 to get to that point, which is the point -2, 3. So a rotation of 3, 2, 90-degree rotation about the x-axis, about the origin, moved to -2, 3. So an XY point changed to a -y x. So now let's talk about 180-degree rotation. Well, 180-degree rotation is just along the same line. I continue on the same line. This would be along this same line. That's 180 degrees. So that point was -3, -2. So 180-degree rotation. 3, 2 changed to -3, -2. So any XY point changes -x, -y. Now a 270-degree rotation was this one over here that I tried to draw before. So I basically need another 90-degree angle in here. Or if I make a 90-degree angle here, so if I go down 3, 1, 2, 3, and then left 2, I'm sorry, right 2, that gets me the point 2, -3, so the point 3, 2 changed to the point 2, -3. Okay, so my x and my y changed. Well, my y came up here, and then my x was negative. Okay? So that's what you need to remember, is you need to remember each one of these. So I'd make sure that you write those in your notes. So the next slide just says this again, okay? Again, remember your symbols. I wanted to explain to you guys why all this stuff happens. Okay, so if you want to write more, you can write more. If you want another visual, you can draw in another visual if you want. Okay, so this hexagon shown below, what is the image of point T after a 90 degrees counterclockwise about the origin? So T is here. And I need to go 90 degrees that way. So look at what your slope is. 1, 2, 3, 4, 5. And so I have, actually I go up 3 over 5. So I kind of look at that like almost like it's a slope. Okay, so my slope is 5 over 3. We just said that an x, y point is going to change to, with a 90 degrees, negative y x. Okay, so my x coordinate, which was 5, 3, that's going to change to a negative 3, 5. They switch locations and the y becomes negative. And kind of showing, that's why I have this grid here, 2, 3, 4, 5, up 3, 1, 2, 3, okay? If I need a perpendicular to this, okay, I have to go up 5 over 3. Now I do have a right angle there. Okay, example 2. Triangle PQR is shown. What is the image of point Q after a 90 degree rotation about the origin? So again, that point is 4, 5. So remember, xy changes to negative y x. So any point 4, 5 is going to adjust to negative 5, 4. Okay, this is the fun part, I think, is now looking at this picture. That picture is super symmetrical. So I want a 90 degree clockwise rotation of AB around point P. So this segment has a 90 degrees. So look at where A is and look at where P is. How could I get point A rotated 90 degrees? Well, that comes over to G. B rotated would be H, so that is, clockwise rotation. Ha ha ha. So clockwise rotation. So 90 degrees here would be over here, so A would rotate to C, B rotating 90 degrees, you have your 90 degrees there, would rotate to D, so this would be segment CD. And then we have DE. Clockwise rotation, okay, so going around my clock about P. So E's 90 degree rotating, there's my 90 degree angle, is G. D's 90 degree angle is F. So 90 degrees counterclockwise of GH. So clockwise would be that way, counterclockwise is that way. So I start with G and I look at where's my right angle. Here's a right angle, goes to E, H, goes to F, so this is FE. Counterclockwise. So going backwards from what we're used to, EF. So F rotating would get me to B, E rotating would get me to A. Now, 180 clockwise rotation of triangle DPE. Okay, so clockwise, I'm going to rotate D 180 clockwise, so that gets me triangle HP. Now E rotating 180 degrees, that's actually up at point A. Okay, and then 45 degree clockwise rotation of HPA. So counterclockwise, I'm rotating that way. So H rotating 45 degrees is G. Let's do that in a different color. H rotating, because this is 45, so that's H moves there, A moves there, and P stays where it's at, so it's GPH. And make sure you have the corresponding pieces correctly. H rotates to G because that's where my angle is. P stays the same. A rotating 45 degrees pairs up with H. Okay? So that is our video on rotations.